data more accessible through Common Data Models and FHIR API's webinar series. Before we begin, I'd like to provide a brief overview of this project, which addresses the federal priority to expand data capacity or data infrastructure for conducting patient-centered outcomes research, abbreviated PCOR, that informs decisions about the effectiveness of health interventions used in the Medicaid and children's health insurance programs. The transformed Medicaid Statistical Information System, known as T-MSIS, has analytic files that are suitable for research, known as TAF as part of a new research-optimized national Medicaid dataset that begins in 2014 with full representation from all jurisdictions in 2016. These files include data on Medicaid and children's health insurance program enrollment, demographics, service utilization, and payments. This project created open source code to format these data into the FDA Sentinel and Observational Medicaid Outcomes Partnership Common Data Models to improve data access, accelerate analyses, and enable multi-database studies. The aim of this webinar series is to educate researchers who are using or plan to use Medicaid data about the new data transformation tools and disseminate major findings. Each video in this webinar series is a chapter that covers a key project objective. My name is Michael Stagner from the Duke University School of Medicine, Department of Population Health Science, and I'll be leading this chapter, which discusses creating a mother-infant linkage using TAF data in the Sentinel Common Data Model. I'm an analyst programmer in the Department of Population Health Sciences, and I work primarily with processing and curating large healthcare data resources such as Medicare and Medicaid. Please note that the views expressed in this presentation are those of the authors and do not necessarily reflect the official position of the U.S. Department of Health and Human Services or the Food and Drug Administration. The work discussed in this presentation was funded by the Office of the Secretary Patient-Centered Outcomes Research Trust Fund, which was made available to FDA by the Office of the Assistant Secretary for Planning and Evaluation through an interagency agreement. The US FDA funded the Sentinel Initiative contract. The agenda for today's topic, today's chapter, is the overview of the Sentinel mother-infant linkage process and mother-infant linkage in the Medicaid and Children's Health Insurance Program, transformed Medicaid Statistical Information System analytic files. Please note that everything in this presentation occurs after the transformation of the core tables of the Sentinel Common Data Model, the demographic, enrollment, encounter information, and all that is described in more detail in Chapter 1 of this webinar series. So the overview of the mother-infant linkage process. The linkage of mother and infant data is critical to evaluate infant outcomes in relation to important public health questions. Longitudinal data like that are available in the Medicaid TAF allows for studying mothers and infants. It's a unique, fairly unique data set, and it's critical for studying potential adverse effects of prescription medications. I believe over 4 in 10 pregnancies in the United States deliveries are covered by Medicaid. So it's obviously a very good resource for doing this type of analysis. So these are all the tables that are prescribed by the Sentinel Common Data Model. In the initial phase of transforming the data, you'll create the core set of tables, the demographic and enrollment information on the beneficiary level, and then also their healthcare utilization information, which is their dispensing, prescription drug dispensing information, encounter healthcare utilization, and then diagnoses and procedures. We also create facility and provider lookup tables for facility location and provider specialty, and those link back to the initial core tables. Then in this webinar, we'll be discussing mother-infant linkage, which is sort of the second part after you've already transformed the utilization information. And more information on all these tables can be found on the Sentinel initiative.org site. So for creating the mother-infant linkage table within the Sentinel Common Data Model, the first step after transforming the initial core tables is to identify deliveries and infants. So identifying sort of the population of mothers and children that can be linked together for this table. Performing the actual linkage. So once you've determined the beneficiaries eligible for linkage, finding out how you can pair those beneficiaries up, checking for quality assurance on the back end, making sure that what you're seeing after linkage has been performed actually makes sense, and then outputting the final table, which can be queried for analysis in concert with the other SCDM tables available. So deliveries are identified in the encounter data, and there's a set of requirements for determining what is an eligible delivery to be linked to an infant. There's a prior Medicaid coverage, Medicaid enrollment requirement. There's a delivery washout, so that if a particular beneficiary had multiple delivery diagnoses or procedure codes in the data within a certain amount of time within each other, those would be disqualified for identification. There's a set of codes which determine a live birth. And there's also requirements for the beneficiaries that can be determined as eligible to have had a live birth delivery. And that's a sex requirement, an age requirement, that sort of thing. These are when a delivery is determined, identified, this is the set of information that's saved away by the mother-infant identification package. And so that's one table of data that will be used to merge to the other table, which is the table of identified infants, which also has an ID, the birth date, which should be relatively close to the delivery date for linkage, the sex of the infant, and also their enrollment information. The current mother-infant identification package requires at least 1 day of enrollment with medical coverage during the first 3 years of life, and that's to create as wide a sweep as is reasonably possible to make sure that infants that are in the data are actually picked up by this identification process, so that that they can be hopefully successfully linked to a delivery in the data. If you have a smaller restriction on this, like a year, you'll be losing a lot of potential matches because of the way that the data are initially captured. It's possible that all the delivery information, for example, could be under the mother's patient ID, and then it wouldn't we wouldn't be able to sort of tease out that individual infant. But later on down the road, that infant gets their own ID within the system, then we'll be able to link them. So it's just you'll see later that sort of infants might be shown in quotes because up to 3 years, the 3-year-old child isn't really recognized as an infant anymore. But we want to be able to pick up as many potential matches as possible. So at the actual linkage process, we have a set of live birth deliveries, and we have a set of infants, and we want to match them. The date of birth and the date of delivery should be close to each other. And then the ways that you can match those infants and deliveries is with a family subscriber number, which is what we use in the Medicaid and CHIP data. The sort of gold standard is a birth certificate with names and addresses, and in other data, those might be available to you, and those would provide you with a very high quality match, one that you would feel very confident in. So applying those ideas, that thought process of identifying of linking mothers and infants, how does that apply to the actual Medicaid and Children's Health Insurance Program data? So the TAF data, research optimized version of the T-MSIS data. And again, if you'd like more information about that, I would encourage you to check out chapter 1 of this webinar series. The CMS periodically releases updated versions of the TAF data as higher quality data become available, and depending on what is approved for a specific user, they can expect that their data may be in a slightly different format than what's described in this webinar, because a user may have access to the 100% files, which are monthly, and that's what's used for this transformation process and linkage, or maybe extracts, which are annual data and are based off of the 100% files. And also the VRDC computing environment available to Sentinel is labeled as a federal contractor level, and so the data structures may be slightly different, and the computing resources available may be different. So the code that we'll take a look at later may need to be modified for yours or another user's specific purposes. So specifically for Medicaid and CHIP, we're looking at the time period of data available encounters. So we're looking at women that are 10 to 54 years old at the start of the encounter or the delivery. And there's the washout period. So no evidence of any other deliveries within the 6 months prior to a delivery, and mothers must have had medical coverage for 90 days prior to the delivery. In the initial version of the mother-infant linkage, this medical coverage restriction was 180 days, but that has since been changed for subsequent versions of the transformation or the linkage process because um, with Medicaid, it covers so many deliveries, so many births in the United States every year, but it may not the beneficiaries may not necessarily have been on Medicaid before they even knew that they were pregnant or became enrolled in Medicaid because specifically because they discovered that they were pregnant. And so with 180 days, 6 months of coverage beforehand, uh, a lot of a lot of mother and deliveries were not identified because that wasn't necessarily uh, the sort of the rule that mothers had a lot of previous coverage, and so that was changed to 90 days, and uh, this recommendation was made by an expert panel after reviewing the results of the initial linkage. Again, infants are in quotes here since the return from the data set is anyone identified up to 3 years of age to make sure that we've got as large population to be able to link as possible. So yeah, keep that in mind. So in reference to the types of linkage, how the linkages are made within the Medicaid and CHIP TAF data, the option available to us to make linkages is the T-MSIS case number, which is an encrypted ID that's jurisdiction assigned and is used to identify a Medicaid case and often acts as a family identifier. Here's a screenshot of the documentation for this variable on the ResDac website. We do not have any sort of, uh, individual identifier information in the TAF data, so we don't have anything like birth certificate information or names or addresses, anything like that. That's available for these uh, research files. So we rely on this case number. So in order to determine legitimate links between mothers and infants, we're trying to get the most accurate linkage, obviously. So both records have to come from the same jurisdiction. They both have to have that same encrypted case number, and the date of birth has to be close to the admission and discharge dates for the delivery. So an infant's date of birth has to be between 3 days before or one day after a delivery date if discharge date is unknown. If discharge date is known, then the date of birth has to be between 3 days before the admission date and not after the discharge date up to 180 days. More restrictive eligibility requirements can always be applied in the analysis phase. So if you were to do this linkage and then wanted to run an analysis and wanted to restrict it down to date of birth has to always be within one day of the delivery date. That's always something that can be applied later. So if you want to run the R code for transform or for linking mothers and infants in the Medicaid and CHIP TAF data, the code pack is available on the Sentinel Git repository. And again, this is sort of a two-step process in that you have to create the set of core tables in the phase A ETL process. And the core tables, again, are demographic and enrollment information, as well as healthcare utilization and prescription drug dispensing. And once those tables are created, then they during the QA process, the quality assurance process for that, mothers and infants are identified from those tables, and those two tables, one for live birth deliveries and one for infants in the data, they can be linked in the second step of the process after the core tables in this mother-infant linkage coding, also referred to as phase B. So when we run the code on the Allstate Medicaid and Children's Health Insurance Program TAF data, we're able to generate an overall linkage of 63% of the mother's delivery records. So about 5.2 million out of 8.3 million eligible deliveries as determined by the mother-infant identification package from 2014 to 2021. Now, the final SCDM table for mother-infant linkage actually contains all the linked deliveries in infants, and also all the unlinked deliveries in infants as well. And so if you're looking at the data from the final product, you want to make sure that when you're looking at linkage, you're using a denominator just of identified deliveries, because if you use that table and just used all the records, which includes all the identified infants, your linkage percentage wouldn't look correct. Here's a map of what linkage looks like on a jurisdiction level. And you can see that for the most part, 39% of jurisdictions had a linkage rate of over 75%, which is pretty good, and matches up pretty well with other attempts at doing linkage with these data, or other linkages with that might have information, for birth certificates or that sort of thing. There's 4 that had a linkage rate between 50 and 75%, so not quite as good. And then 10 that had a linkage rate of under 50%. And you can see some of these, like Kentucky and Alabama, they don't contribute any data to our final SCDM tables, so there's no linkage there. And then some of the other jurisdictions just have a generally poor linkage. The challenges are that when we're using our TMSIS case number, several jurisdictions that have practically no linkage at all, is because the case number is unique per beneficiary. So the TMSIS case num is not acting as a family identifier. Again, this is a jurisdiction-specific variable, and each jurisdiction can put whatever information in there. And so for those jurisdictions, they're obviously using that value as some sort of patient level, beneficiary level identifier, because it's not common across families. Other jurisdictions had high rates of missing case numbers. Obviously, if we don't have any TMSIS case nums, where we're not going to be able to do any sort of linkage. Further exploration of jurisdiction-specific Medicaid program rules could lead to better matching down the road. We did have an instance where it was discovered that New Jersey did have a unique identifier, but on the end of the identifier, they added a 2-digit person identifier. So the first 10 digits of the BMSIS case num actually acted as a family, a case number. But with those 2 extra digits on the back, they looked unique, and we didn't get any matches. But once we discovered that that was the logic behind how they created their case number, we were able to remove those last 2 digits from the ID and create a linkage for New Jersey deliveries and infants, which was in line with the linkage rate for other jurisdictions. And again, you can see that the majority of jurisdictions have a good, a 75 plus linkage rate. And it's just those jurisdictions where we're not able to rely on the T-MSIS case number for linkage. And then here's some general information about linkage, and that the majority of linkages are in an inpatient healthcare setting, which is what we would expect. And then there's a smaller number in outpatient or emergency department, that sort of thing. And then same for birth type. The majority are singleton births, but we do have multiples, twins and triplets. And then somewhere the information available doesn't allow us to determine how many infants were in the live birth. And for the typical settings, our linkage rate is about what the overall linkage rate is. And then in the atypical situations, our linkage rate isn't quite as good. Then finally, there's a QA package available that SOC creates to assess the data quality of the actual linkage. The quality assurance of the mother-infant linkage package setup is very similar to the core tables or phase A process. But it has different checks. It's focused primarily on that one single mother-infant linkage table, and so the checks it's running are specific to linkage. And if you'd like more information about the package, that can be downloaded from the Sentinel Git repository, and the questions can be emailed to info@sentinelsystem.org. Finally, I'd like to thank you for your interest in creating a mother-infant linkage using TAF data and the Sentinel Common Data Model. If you'd like to learn more about the Making Medicaid Data More Accessible through Common Data Models and FHIR APIs project, please follow the links shown in the description field below.